Assalamu alaikum. My name is Abdurrahman Makin. The topic that I'm going to discuss today is the Saudi steel industry, a brief history and future prospects considering the recent development. In recent years, several large-scale projects and initiatives have been announced as part of Vision 2030. Many of the goals set by the government have a direct impact on the steel industry. In addition, new sectors is expected to be developed in coming years, such as automotive and renewable energy. Such profound developments generate a need to forecast future demand in order to recognize and anticipate market gaps and potential opportunities. The motivation of doing this study is to cover the scarcity of research in the local steel industry, with the objective of providing three scenario forecasts for the steel demand in KSA up to the year 2030. By implementing a qualitative method using Delphi technique and a quantitative method using regression analysis. This study also highlights the challenges surrounding the implementation of the huge projects proposed by the Vision. According to this study, the demand for steel in Saudi Arabia could potentially double in 2030 compared to 2018. I will start with a brief background. So, what is steel? Steel is an iron alloy containing less than 2% carbon and around 1% of manganese and small other amount of other elements. Steel is the most commonly used metal in the world today. It is everywhere in our lives. Also, steel is considered very important for the industrial and development, supporting and driving green economy, since it's almost 100% recyclable without loss in quality. So when did the steel rise? The steel rise in the 19th century with the second industrial revolution. In that period was characterized by new inventions. For example, in electricity, Faraday built the first electrical generator, and Frederick Taylor, who applied scientific management theory to increase the industrial efficiency, and also Henry Ford, who designed his first moving assembly line. So steel was very important at that point of time for the transport and the commerce. During the period from 1850 to 1860, a new technique was developed that allowed mass production for steel. This technique is primarily linked with Henry Bessemer, who is an English inventor. The Bessemer process was the first inexpensive industrial process for the mass production of steel. So, today, steel is produced in two main methods. The first is the basic oxygen furnace, and it accounts for 71% of all the steel produced worldwide. And the second is the electrical arc furnace, and accounting for 29% of all the steel produced worldwide. In 2018, the steel demand reached 1.8 billion. And with building and infrastructure dominating the usage with 51% of the total usage, followed by mechanical equipment with 15%, and automotive with 12%. So these three sectors account for nearly 80% of the steel usage. Moving on to the global steel industry. Steel demand has grown over the years from 850 million tons in 1983 to more than 1.8 billion tons in 2018. The global demand for steel increased at an accelerated rate over the period from 2000 to 2008, effectively doubling over a short period of time. The rise in steel demand led to huge capacity expansion that generated overcapacity. The overproduction capacity has led to trade tensions in recent years. In 2018, the United States has imposed several trade actions on China, including steel imports. So, by 2019, the global growth was at its lowest level since 2009. The growth has declined as a consequence of increased tensions. Slowing global economy and investment have hit key steel using sectors globally. In addition, the overcapacity and trade tensions are negatively driving the global steel prices, which directly affecting steel manufacturer bottom lines. Moving on to the Saudi steel industry. The rapid development in the GCC countries, especially the high infrastructure spending, has resulted in a huge demand for steel from these economies. In KSA, the demand for steel surged during the period from 2009 to 2014, doubling the demand to a historical peak of around 14 million in 2014. Following this peak, the demand suffered in the last 3 years and gradually declined to 9 million tons. So, Saudi Arabia and the United Arab Emirates are the main producer of crude steel in the GCC regions. Together, they account for more than 65% of the steel output in the GCC. If we take a look at the MENA region, in 2018, production-wise, Saudi Arabia was ranked third. Also, it was ranked third in terms of export after Iran and UAE. In terms of imports, it was ranked second after UAE, with most of the imports coming from China. Moving to the Saudi steel challenges. In general, the steel industry consumes a huge amount of energy from direct electricity and natural gas. For years, low energy subsidies were always considered a competitive advantage in Saudi Arabia. However, in recent years, Saudi Arabia has introduced a new energy regulations at which energy prices have increased according to the energy demand challenges globally. Also, raw material prices have increased substantially during the past decade. So, the Saudi steel industry is characterized to be highly fragmented and complex. It is mostly commoditized and differentiated market, almost entirely driven by public expenditure. It is focused on long product for construction, which created an overcapacity in that sector. It has low downstream integration and lack of backward integration to iron ore. Also, the Saudi steel industry rely heavily on imports, The graph shows that 58% of the aggregate flat product demand for the last 10 years is fulfilled by imports. And also, some products is relying fully on import with 100% imports, such as plate and electrical steel. The Vision 2030 and future demand drivers. KSA Vision 2030 is an ambitious vision for shaping KSA future. The vision goes beyond the economy and seeks a prosperous, efficiently run society. The vision aims to double the GDP in 2030 compared to 2014. It seeks to double the GDP from $800 million to more than 1.6 billion, doubling the GDP from $800 billion to more than $1.6 trillion into 2030. It also aims to create 6 million jobs by 2030. This will require a huge investment of $4 trillion. So, with the Vision 2030, many new industry will emerge by the target and objectives of the vision that will potentially create opportunities to grow the steel sector. Also, existing industries is expected to grow as well. For example, for the automotive industry, Vision 2030 aims for 300,000 vehicles manufactured annually in Saudi Arabia by 2030. And another example, the power generation. Saudi Vision aims to build nuclear power reactors in King Abdullah City with 17.6 gigawatt. Also, it aims to build wind power generators with 16 gigawatt of capacity. It's the same case in economical and industrial cities. In Saudi Arabia, it's expected to see rapid growth. For example, we have NEOM, we have King Abdullah Economical City, and Jeddah Economical City. It's the same case in the residential sector. The Ministry of Housing have a plan to build at least 500,000 affordable houses by 2030. So, putting all of these in mind, we'll move to the demand forecasting. We'll start with the first method, the qualitative method, Delphi technique. So, in applying Delphi technique, the first step was to select the team. So 4 of the marketing experts were selected to do the forecast. The requirement was that each member of the panel should provide 3 scenarios for the future steel demand in Saudi Arabia for the next 10 years. High case scenario, most likely, and low case scenario. Then all the individual feedback were collected, aggregated, and summarized, and then sent, and the summary was sent back to each individual expert. Then they have a chance to refine their forecast based on the summarized data. And after multiple rounds, the team reached to a consensus, which is reflected in the final forecast result. And this slide shows the assumptions used for the Delphi method. There are scenario-specific assumptions, and there are general assumptions. The general assumptions were used in all 3 scenarios. To have a look at the final forecast result from Delphi technique, the low case scenario takes to account a slow recovery of oil prices. The prices will not recover until late 2023, followed by a moderate growth in demand up to 2030. Most of the demand will recover. It will start recovering from 2026 onward. The high case scenario takes into account a very quick recovery of oil prices by 2021. Then a moderate growth from 2021 to 2023. And from 2024 to 2023, it's expected to have a boost in demand. The high case scenario projects the demand in 2030 will be double the demand level in 2018. The most likely scenario assumes that slow recovery of oil prices. The prices will not recover until late 2022, followed by a moderate growth from the period from 2023 to 2026, and then a substantial growth from 2027 to 2030. The most likely scenario projects a 66% increase in the demand compared to 2018 by 2030. Moving on to the regression models. The first step was to construct a scatter diagram to examine the relationship between the dependent variables and the explanatory variables. So the dependent variable is the steel demand, and the explanatory variables are real GDP, construction spending, GDP per capita, the GNP, and GNP per capita. The scatter diagram indicates that there is a positive linear relationship between steel demand and real GDP, GNP, and construction spending. So, likewise, also the scatter diagram shows that there is a positive linear relationship between the steel use per capita and GNP per capita, as well as GDP per capita. A total of six regression models were constructed using Minitab software, and the results are summarized in the table. So the R square observed indicates a strong relationship between the dependent variable and the explanatory variable. So 3 variables were selected to forecast the future steel demand using double exponential smoothing. So the real GDP, the GNP, and the construction spending were selected and forecasted to the year 2030 using a double smoothing, exponential smoothing. The forecasts for 2020 were adjusted to reflect the expected economical contraction. The forecasted econometrical indicators were used to forecast the steel demand for the period from 2020 to 2030, as shown in the table. So the average prediction of lower limit was 15.4 million tons of steel demand in 2030. The average predicted fit, the most likely, is 17.6 million by 2030. And the average upper limit is 19.7 million tons of steel by 2030. So, comparing the result obtained with the method used in this paper, which is the Delphi technique, and the result obtained by regression method, we can see that in the high case, the figure estimated using Delphi method yielded a comparable estimate to the one using regression models. The disadvantage of the forecast obtained by regression model is its dependency on the forecast of explanatory variable. The big variation between the high and low case estimates using Delphi method reflects a great deal of uncertainty due to the rapid changes of the global economy, which create an ever-changing environment. The amount of uncertainty is rising with time, and the economy is changing in a rapid pace, which puts more pressure on organizations to keep up with changes. Overall, companies should rely on more frequent and focused short to mid-term outlooks to minimize the risk of fast changes in the market. The Delphi method is found suitable in the case presented in this study, as there are not enough data to construct more sophisticated forecasts. So, in conclusion, the outcome of this study is summarized in 10 points. The first point is that the industry should focus on closing import gaps by allowing private sectors and foreign direct investment to localize the supply of new generated demand, such as rounded billets in the midstream and plates and seamless pipe in downstream. The industry should strategically emphasize on backward integration of iron ore, internally or abroad. The vision is focused on improving the attractiveness of such investment. Also, SABIC is moving forward with Mauritania mining project, Takamul. Steel manufacturers must reassess their operations and operate more efficiently to reduce the impact of rising energy costs. For example, Hadid, which is the largest steel company in Saudi Arabia, have implemented several energy and sustainability programs to optimize its consumption of energy, both in electricity and natural gas. For example, reducing and recycling the flared gas generated from direct reduction plants. The companies do need to refine existing steel grades and producing value-added and special steel products, which is necessary to unlock new emerging applications, such as automotive and renewable energy. Also, another point to stress on, the government should enforce adherence to SASU standards in order to regulate the market and eliminate low-quality producers. The Saudi steel industry should take advantage of being the GCC's only flat producer and invest in improving quality, expanding capacity, and strategically plan for forward integration to drive growth through all stages of the steel value chain. The steel industry and GCC need to impose coordinated trade action to prevent exports being diverted to GCC as a consequence of US trade actions, especially in long product. Also, further restructuring of the steel sector is also required to create cost-effective and competitive players who can compete globally. In addition, two more points relating to the forecast. As uncertainties rising with time and the economy changing in rapid pace, organizations should not rely entirely on long-term forecasts for decision-making. A more frequent and focused short to mid-term outlook should be applied to minimize the risk of fast changes in the market. The last point is that Vision 2030 have the potential to deliver a massive uplift to the steel demand in Saudi Arabia. However, it is unlikely to see substantial boost in the steel demand during the coming 2 to 3 years. Thank you very much for listening. That concludes my presentation.